Thank you. We're going to resume our aeronautics aviation session with the researchers. Now, let me begin by informing you that if we wanted to have a full day on aeronautics research in some other week of the year, we wouldn't have any problem. But I wanted you to know that we've probably got a couple of dozen Texas researchers in aeronautics who are at a conference sponsored by the American Institute of Aeronautics and Astronautics in Florida. So I don't want you to think that this is the total representation of research, and I know you wouldn't think that. In Texas, we have lots of really good aeronautics research. The 5 gentlemen that we have here today are representative of certain areas of aeronautics research that I think, and I hope you will think, are very interesting. And you will see the tie-in to the points made by our previous speakers. Industry facing challenges in technology, facing challenges in their business environment, and facing challenges in workforce. I think you'll enjoy these 5 presentations by active researchers, and we'll start off very first with Mr. Jerry Hendricks from Texas A&M Corpus Christi, who's going to talk about UAVs, a really hot subject in aviation today.
Thanks, Norm. Maybe we have the best researchers here, I don't know. So yes, that is a drone. It is flying around Dallas-Fort Worth International Airport. Part of the research that we have conducted for the Federal Aviation Administration looking at counter-UAS technologies. And we actually were able to test in Dallas-Fort Worth at night and during the day, playing nefarious activities, flying aircraft into and around the DFW airport. While there's active aircraft in the area, if you look at the bottom corner of the chart, you'll notice the Emirates Air is taxiing. I can imagine they wondered what was happening when they looked out their window and saw a 7-foot diameter UAV flying close by. We've come a long way from the Wright brothers' days of 1903 in Langley Aerodrome. If you haven't read David McCullough's book on the Wright brothers, I recommend it highly. Go take a look at it. It's an excellent, excellent book. So we've come a long way. Earlier vision for drones in the 1900s were looking at things like the Dayton Wright Airplane Company coming up with the aerial torpedo drone, which basically looked at a first usage of unmanned aircraft beyond visual line of sight and established in 1946 the U.S. Air Force Special Pilots Aircraft Branch. The vision for the future is, yes, the Jetsons. We've heard about that today. General Motors in 1956 had an 8-minute commercial that dealt with autonomous systems and actually operating on superhighways and actually driving and operating across the United States. And the Gerodome QH-50 Dash in 1962 was an actual aircraft. It was developed to be an anti-subchaser, and one of the gentlemen that works with us actually worked on that program. Today, we're actually doing package delivery for major corporations. You hear so much about Amazon and their announcement. There are a lot of other commercial entities out there that are doing package delivery. Uber with their concept of Uber Elevate, and also disaster response. And that's a photograph from our Mission Control Center in Corpus Christi, Texas, and I represent Texas A&M University in Corpus Christi. We're actually doing flights after Hurricane Harvey. The ship channel was shut down for 7 days in Corpus Christi, and we had to put up temporary flight restrictions to allow operations to be conducted during that time frame. And we heard about Bell's Urban Air Taxi. This is images of their cockpit that they released at the Consumer Electronics Show. The future has high-altitude, long-endurance aircraft, Boeing with a commercial concept of an unmanned controlled aircraft. And then I personally like Cogsworth and the fact that someone can come do all my yard work for me. That would be really, really nice. And then I had to throw in something from an ag standpoint. So somewhere in Texas there's a ranch, and there's some ranchers out there, and they deploy an aircraft which deploys medical drones that goes out and scout drones and looks at health, looking at herd count and herd location, and also meds delivery. Could look like this. Can you start the sound, please?
Jane is right.
So from our friends at Alcoa Aluminum, now called Aeronautics, the U.S. national airspace integration is a very complex problem. It's bounded by politics and also the regulations and the laws that we have to govern and have to utilize. And then looking at the maze of things that goes into just the development of aircraft, not only working with different entities like NASA and the Federal Aviation Administration and other corporations, yet sensors and all kinds of things that are a part of the CONOPS of actually integrating into the national airspace. It's a big, complex picture. This is a graphic we picked from NASA to show that as we continue to introduce unmanned aircraft systems into the national airspace, it becomes more and more crowded. So what did the FAA do about that? So first, let me get to talk this. There are a lot of drone applications in the state of Texas. We're number one in road and bridge inspection and looking at things like agricultural and oil production monitoring, power line inspections, railroad track inspections. I didn't realize we were number one in the nation in railroad tracks. Wind turbine inspections, and of course we have a large border, and then the ports, 4 of the top 11 ports are in the state of Texas. So there's a lot of UAS drone applications in Texas. So with that complexity, what did the FAA do about it? A few years ago, they established the FAA UAS Test Sites. Originally, there were 6, then there was one that was added by Congress in New Mexico. We're the Texas FAA UAS Test Site, known as Lone Star UAS Center of Excellence and Innovation. We kind of like to look at it this way. And we have 68,000 square miles of test ranges in the state of Texas. That's larger than the state of Mississippi, for all our boys, our friends from Mississippi State. And it's larger than the state of North Dakota, which is one of our rival test sites. But we're the world's 12th largest economy, excellent real-world surroundings in which to do test in. 68,000 square miles is a lot of ranges. We were stood up to safely integrate public and civil UAS operations in the national airspace, to conduct research and development, to gather information, to development rules, regulations, procedures. It led to recently what's called Part 107, which you may have heard, for commercial operations. And the governor asked us to serve as an economic engine for the state. We're composed of ranges, command centers. We have mobile command centers, a central command center in Corpus Cristi, Texas, roughly comparable to an airline operations center, modeled after Mission Control at Building 30 in NASA, and also after tactical operations centers, which some of us had worked in. Radars, we have a series of radars that we utilize for our testing. We have drones. The numbers continue to go up every day. We probably got about 30 or 40 different drones that we utilize, 7 or 8 in the same family. Tools that we use to survey our testing. We have to follow all the rules, regulations, procedures that the FAA has established. And we support education, research, and we offer services. And people ask me from time to time, what is your business case? Well, the business case is we help manufacturers with new and exciting aircraft and testing them in the national airspace. We help people who come in with an idea. For example, how do you inspect railroad tracks with drones? One of our first customers were BNSF Railway, which is now one of the leaders in the aviation industry, utilizing unmanned aircraft systems. And their first question was, what can we do? There's still train robberies. We got to get people off the track. How can we utilize aircraft to help there? So that's part of our business case. And then research that we do with NASA, and I'm going to talk a little bit more about that, and the people that we have, where we brought in people from all over the United States to be a part of our team and work with us from major manufacturers, major industry. 68,000, we kind of distributed like this, a lot of testing in the South Texas area. We too have had a great experience working in South Texas in this community that people really want to help with us, and they've enjoyed being a part of our team. This is kind of our focus primary area. Sense and research, sense and avoid, part of our research. Counter UAS, which we started with. Beyond line of sight operations, autonomous systems. We've done more package delivery than most anyone else that you read about on the internet. We just don't talk about it. And the reason we don't talk about it is because the clientele that we have is very sensitive to that business case. UAS traffic management, working with NASA, and also something called the National UAS Credentialing Program, where we actually credential operators to operate on behalf of the oil and gas sector. Working with NASA, 2 primary areas, UAS traffic management, as I just mentioned, 5 major tests we conducted. The most recent one was in December, and we're also working with detect and avoid. And so we're putting a radar on this aircraft. It's about the size of your cell phone. I don't know if you can see that or not, but it's about the size of my Super I+8 or whatever it's called. And then, and we also have been working with NASA through a Chancellor's Research Initiative on the Expandable Vehicle Autonomous Architecture, which is onboard software. We actually sent 3 people to NASA Armstrong to help them develop the software, and it's now becoming an ASTM standard, and basically to help you avoid those bad things as you fly and working in the sense and avoid area. We talked a little bit about this earlier. This is from our test that we completed up at DFW. We're playing high-tech hide and seek, if you will. And it was a very interesting test. Took about 8 months to set that up and get it operating. We do credentialing, as I mentioned, as a stakeholder advocate for major oil and gas corporations. You can see their company came in to do testing. This is actually a flight at RELIS up in College Station, where we're actually testing them. In this case, they have to do avoidance around major obstacles and things of that nature. Pretty robust set of tests. There's like 100 different questions they have to answer. If they miss one, they fail, they start over. And then they have to go through a flight demonstration. They have to follow all their operational rules and procedures. And if they miss a step, they start over. And down to the fact, if you don't bring your fire extinguisher, you don't pass. So things of that nature are part of the credentialing program. We do UAS training, and I'm excited that the Texas A&M University system, a large $4.5 billion a year or so university system, adopted a single set of operational rules and procedures for operation of UAS in the national airspace for all their researchers, and we all follow the same rules. And as subsequent to that, we offer that to others to do training. We support education with college-level curriculum. Some of us teach from time to time. We do have summer institutes on drones and UAS activity. We have a drone expo, and then we also have an I-Core lab to bring in students to look at the problems at hand. And it's amazing the capabilities of these students and what they can accomplish in a short amount of time. And so we begin to bring in interns into our program, and we hired several of those interns, not only from Texas A&M University in Corpus Christi, but also in College Station. We also do some agricultural, really cool things in ag, looking at working with AgriLife research and determining plant height and things like that. In this case, a sorghum plant, and what we can do with sensors is pretty amazing. We also support with University of Texas Arlington Research Institute, the state of Texas Department of Transportation, looking at UAS standard operating procedures, requirements, and guidelines, and then also TxDOT and others for the operational credentialing. We supported Hurricane Harvey, large disaster response, as you guys know. We worked in Aransas County search and rescue, surveyed the Port of Corpus Christi, Houston flooding. We did some platform assessments offshore and also at Port Mansfield. Working with Boeing Scan Eagle in situ with 3 primary missions. This again from our Mission Control Center. This just shows an interesting reason I put these insets in. Some houses were gone, some were blown, the tops were blown off of them. All the trees had lost their leaves. Pretty remarkable as a landfall there in the Rockport, Aransas County area. Many lessons learned to go with this. I won't go all over all of these, but the one thing to note is it's important to work with incident command at the local level, state level, and national levels. So what's next? What's next for us is establishing a ready force and equipment for disaster response. Texas has recognized the need for using and controlling UAS as a part of that state emergency response because of the fact that there were so many people who came here to try to help that weren't prepared, and it caused some issues, and we were able to help address some of those. So we've now been designated under Texas Task Force 1 as Texas Task Force Air Wing 1 for regulatory research and also for operations. We're really excited about that. Our first exercise with them is in February. Excuse me, as we'll go to Pastatook, Indiana, to do a mock exercise with 7 other task force from around the nation. So it's an honor to be selected by Texas Task Force 1. What's next? You may hear about Talon, Texas, Arkansas, Louisiana, Oklahoma, and New Mexico. And what that is basically broadening the whole concept of the UAS test site, but for the primary purposes of commercialization. President Trump has established a UAS integration pilot program, and we're going to address those following concepts of operations to help the president figure out how to integrate unmanned aircraft systems in the national airspace to begin that broad acceptance of UAS across the national airspace. So you're going to look up and you're going to see that urban air taxi. You're going to see those blood deliveries going from hospital to hospital, or you're going to see unmanned aircraft systems in the national airspace. And Secretary Chow from the Department of Transportation said we want to reduce regulatory barriers and hurdles to innovation She just announced that this program, there'll be 10 organizations that was selected. The number was 5, now they're 10. 150 people who proposed to this program. We have all the state governments from the states that are listed here, major universities across the state of Texas, and also another universities to be a part of our opportunity here. U.S. commercial markets on the rise, $12 billion by 2022. Those numbers are always debatable, but I thought I would at least add a chart with some projection relative to the market space in 2022. So here are your takeaways. So we've had 100% safe operations, about 3,000 or so test flights. We have clear airspace for testing and operations. We have a robust research capacity, as we mentioned, we detect and avoid and some of those things. We're gaining more and more national credibility. Air Wing 1 is coming. Watch for team talent, and we're making an impact as a trusted agent. And ladies and gentlemen, thank you for the opportunity to come and speak to you guys on unmanned aircraft systems. And if you need anything from us, just look us up online, and we'll be glad to talk with you at any time. Norm?
Thank you, Jerry. My goodness, these UAVs have come a long way. Questions for Jerry? Those are bright lights out there. Yes, sir.
Okay,
Yep.
Is this on? Can you hear me?
Yes.
Okay, so beyond visual line of sight operations deals with mitigators to providing safe operation in the United States and the national airspace, okay? So the most significant challenge is the technology that is needed to be embedded on aircraft today for specific types of missions. Now, larger aircraft, that's not the case, but typically on smaller aircraft, using those sense and avoid technology, we talked about the radar, it's the size of your cell phone. Well, that one's only gonna give you a certain field of view, right? So as you have more and more of these on the aircraft, it certainly adds weight issues to the aircraft, and that's part of the biggest challenge, the integration of sensors into the aircraft from a weight standpoint and also from an integration to the autopilots and flight control systems. Got one in the middle.
Another? Yes.
I have a question. These things obviously offer great benefit for many different applications, but there's also a negative side in which they could be weaponized and used. Could you make some comments about weaponizing these things and what countermeasures might be needed?
Right, so usages of aircraft and nefarious activities is certainly something of a concern, and a part of the work that we're doing with the counter UAS work with the FAA. And there are technologies that are being developed, and one of the things we saw at Dallas-Fort Worth is the technology that allow you to limit or to stop those particular aircraft from intruding into that airspace. And so there are some things out there like bazookas and things of that nature, different types of guns you can actually shoot at these guys to try to stop them and things like that. But it's like any other thing that's built for the purpose of good can be used for that of something that would be bad. So.
Otherwise, anyone else? Yes.
Just something I was thinking about. When you really have a disaster, it wasn't quite this level for the Texas coast, but Puerto Rico is a case in point, where power's out and you have no idea even the extent or the size of the disaster. Does anybody think about having an army of these ready to just send out and report back? What can you see?
So I didn't go over, for the sake of time, the details of the lessons learned from the disaster response, but one of those lessons learned is that we need to have aircraft that are ready to go within a certain amount of time of landfall, and also to deploy those and have those staged so that they're ready to be utilized. In that situation, that's something that certainly should be considered, and we have a situation like what happened in Puerto Rico.
Yeah, I think so.
Yeah.
Thanks.
Okay. Thank you very much, Jerry. Very good.
Thank you.